Hey everybody, Mr. Jones here. We're going to be talking about some group factoring, okay? And to intro that, I want to go over just a little bit about foiling again. We've been talking a lot about that, but FOIL is our process of multiplying two binomials together, right? First, outer, inner, last, right? It's our order, okay? Now I want to explain what I have shown here, okay? These two these two different ways of writing this is actually the exact same, not the exact same, but these are equivalent to each other, these two ways of writing this, okay? Because think about this. If I was to FOIL these two together, if I was to multiply these, 3x times 2x would be 6x squared, and 3x times 7 would be positive 21x, right? What I did there was I did first in outer, right? Now look what I have here. 3x times 2x plus 7, right? I basically wrote it as the first term multiplied by the second group, okay? And again, that will give me the exact same thing, okay? And I'm not even going to write it. But, right, then inner and last would be negative 2 times 2x and negative 2 times 7, right? So if I did that, it would be negative 4x and negative 14, okay? And again, I have it shown in the second group here, negative 2 times 2x and negative 2 times 7, right? So it's the second term distributed to the second group, okay? So do you see, I hope you see how these two are, this is equivalent to this with what it shows, okay? So even though it doesn't look the same, like it has this extra 2x plus 7 group in there, which is kind of weird, but these are equivalent to each other, okay? It's showing that this is distributed to both of these and this is distributed to both of these, okay? And then again, if I combine these, I would get 6x squared plus 17x minus 14. Okay, so anyway, the big thing I just wanted to nail down here was that these two are equivalent to each other, okay? And so when we see, and the reverse is true too, so when we see this, okay, like that's what a lot of these group factoring problems are going to look like. When we see this, we can rewrite it as a FOIL problem, right? So when I see this, I can rewrite it as the two outside terms in a group, 3x minus 2, and then these matching groups account for just one of your other groups, 2x plus 7. It's a weird 2. But anyway, so this is equivalent to this. So I can write it both ways, and they're the same, okay? So that's important to know as we get into group factoring here, okay? Let me put a couple examples on the board, and we'll get into it. Okay, so here's some examples that I have, okay? And the directions say factor these into two binomials, meaning a binomial is just a group with two terms in it, right? So x plus a number, or again, it doesn't have to look like that exactly, but a binomial, just two terms, okay? And so a problem like number one, again, we talked about that just now, how when you have this form of when you have two matching binomials, okay, but then two separate other numbers that are being distributed to both of those, okay, this could be written like a FOIL problem or like two binomials, okay? So how I would write this, how I would factor this is basically all the work's done for us. I just have to sort these numbers into the right spots. Okay, so the first group is going to be, again, my two outside numbers, 4x plus 1. Okay, 4x and positive 1. And then my second group is just these matching ones, right? So it would just be x minus 3. Okay, you just write that once. And that's it. Okay, that is written as two binomials. Okay, so when it's given to you in this form, you're good. That's basically all sorted out for you. You just have to put it in those groups. Okay. Now looking at number two, though, we're given kind of a step before this one. Okay, where this would be a polynomial, and I have to factor this into two groups like this. Okay. So what I'm going to do here, again, I'm going to group this. Okay. So what I'm going to do, I'm going to sort this. Kind of think of it as two separate groups of two, and I'm allowed to do that. Okay. So I'm going to ignore this second part right now, and I'm just going to focus on this x squared plus 8x, okay? So again, I want this to look like this, okay? Because when it looks like this, I'm able to just put it in my two binomials, and then I'm done, okay? So again, I'm ignoring that second two terms. I'm just looking at these two, okay? And what I want to do here is I want to find the GCF of just these two. And then separately, I'm going to find the GCF of these two after. But so I think x squared and 8x. Okay, what's the GCF of those two terms? Okay, well, they both have an x, right? This has 1 and this has 2. So in common, we'd say they have 1x, or x to the first, right? And this doesn't have a coefficient. Well, it has a coefficient of 1, and this is 8. So they have a 1 in common as a coefficient, but we don't really need to write that because it's implied here already. Okay, so GCF here is really just x. Okay, and then again, if you remember, when I factor out a GCF from something, I divide it. I divide both of these by the x. Okay, and I'm not dividing, again, these two are just totally ignored right now. Okay, so I have x, and then I divide both of those by x. So x squared divided by x, this could be an x, right? Because that's 2x's divided by 1x, give me just 1. And then 8x divided by 8, the x's cancel, and so I'm just left with 8. Okay? So now, here's what I want to do, okay? I want to do the same thing with that second group, okay? But there is an awesome kind of check for this one, okay? So I want to find the GCF of these two, okay? But remember what's key. What's key is that these two groups are the same, right? And that's what's going to go in that second group. So I also want this second group to be x plus 8, because that's what this is, right? And if that happens, then I can just go right into writing my answer, okay? But my GCF also has to match up with that, okay? So I kind of have to work together here and think, okay, negative 3x and negative 24, what's the GCF there, okay? And it's tricky here because these are both negative, right? So negative 3 and negative 24, right, in common, right, they both don't have an x, so we wouldn't include an x here, okay? 3 times 1 is 3. 3 times 8 is 24. So these both have 3 as a common factor. Okay, but look, if I multiply these or divided both of these by 3, I would be left with, right, negative 3x divided by 3 would be negative 1x. Negative 24 divided by 3 would be negative 8. That doesn't match, right? I want it to match. So I'm allowed to say, okay, what if I factored out a negative 3? Okay, because technically those do both have negative 3 as a factor, okay? And if I divide by negative 3 from both, negative 3x divided by negative 3 is positive 1x, because negative divided by negative. And then negative 24 divided by negative 3, same thing, positive 8. Okay, so I'm allowed to do that, okay, as long as it gives me what I want, this matching group, okay, as long as I remember to write this negative 3 outside of there. So that's what I want it to look like, okay? I have this side, it factored out, this side, it factored out. But remember, it's still all one big group. I just broke it up so that I could factor it so that it looks like this, okay? And now I can go into writing my answer, okay? So my answer to this, again, would be my two binomial groups. The two outside numbers make up one group, so it'd be x minus 3 in my one group, and then my matching group makes up my other one. So my other one would be x plus 8. So that would be my answer to this. That would be factoring this group, this polynomial, into two binomials, okay? I know it's a lot, a little nitty-gritty stuff happening in there. Let me do one more with you, and that'll be it for group factoring. All right, we're back. Got number 3 up here, okay? And we are going to group factor this sucker, okay? Again, you can group factor when you see that it's a list of 4 terms, okay? Kind of in this almost solved, like FOIL type of form. Usually it'll tell you to solve by group factoring in the directions, okay, if it wants you to, okay? So anyway, okay, again, steps are break it up into 2 separate groups, okay? So you have 2 groups of 2, okay? And so then I just look at those first 2, okay? And I want to think for this one, all right, what's the GCF of 4x squared and negative 12x, okay? So the first one, you don't really need to worry about the signs, okay? Because we can sort that out with the second one, okay? But 4x squared minus 12x. So they both have 4 as a common factor of the coefficients, okay? And they both have an x, right? This one has 2 x's, this one has 1. So 4x would be the GCF of those two, okay? And so then I divide that out, okay? I divide that out, and I'm left with the GCF on the outside times, right? 4x squared divided by 4x would just be x, right? Because the 4's cancel, one of the x's cancels. And then minus 12x divided by 4x. So 12 divided by 4 is 3. x divided by x cancels. Okay, so I'm good there. That's what I'm left with on this side. Okay, now remember, that tells you a lot about what this side should be, right? Because you want this side to also have the group x minus 3 here. It doesn't really matter what's here, okay, what's the GCF, but you want the groups to be the same, okay? And so to do that, you still find the GCF of these two terms, okay? But again, we have to play with the signs a little bit because we want this to match, okay? So that's going to, figuring out whether the GCF is a positive or a negative, we'll see in a little bit. So 5x and 15, okay? They both don't have an x, so I don't include an x here, okay? 5 and 15, hopefully you recognize 5 is a common factor, right? Because 5 multiplies into both. And so then I divide both of those by 5, okay? But if I do that, negative 5x divided by 5 would be negative 1x, and 15 divided by 5 would be positive 3. That's close, but my signs are off, right? So I'm allowed to do this. Divide by a negative 5, okay? Make it negative, okay? So if I do negative 5x divided by negative 5, I get positive 1x, okay? 15 divided by negative 5 would be negative 3. Good. Okay. And that's not going to happen every time. I know I did it in the two examples that I did, but that's not going to happen every time where you have to change this to a negative. Okay, it happened in these two, but sometimes the signs will already be set and you're good. So just make sure you check for those, the signs are all good as well. Okay, so that negative 5 is written here, and this x plus 3 checks out. That's what you get when you divide. Okay. And now I've got my matching groups, I've got this factored, so I just need to write my answer. So again, that is the outside numbers, 4x minus 5, times the matching groups, x minus 3. So there it is. We are done with group factoring. Thanks for following. I know that's a tricky process, but that's going to lead in really well to our main type of factoring that we'll get into next. Okay, so thanks for following. Good job. Wonderful.